Ja, goedenavond allemaal. Ik heet iedereen van harte welkom op het seminarie van IP6 en Inositol. Ik wil ook de honderden mensen die op dit moment zijn ingelogd ook welkom heten en die het webinar thuis zullen volgen. We hebben vandaag een heel interessante spreker, namelijk professor Dr. Shamsuddin, die arts is, meer specifiek kankerpatholoog, en geeft les aan de Universiteit van Maryland in Baltimore, in de Verenigde Staten. Dr. Shamsuddin is al meer dan 35 jaar bezig met kankeronderzoek en heeft heel wat screeningtests voor kanker ontwikkeld. Hij heeft ook meer dan 200 wetenschappelijke publicaties op zijn naam staan en is dus zeer vertrouwd met kankeronderzoek. Dus het is echt een uitgelezen iemand om vandaag hier bij ons te hebben en om meer in detail te praten over IP6 en inositol, een unieke nutriëntencombinatie met heel wat anti-kanker-eigenschappen. IP6 en inositol is niet alleen een antioxidant, maar is ook heel belangrijk om de tumor te reduceren. Gaat ook de nature killer cell activiteit activeren, gaat ook de celdifferentiatie stimuleren. En het is ook een heel veilig nutriënt. IP6 en inositol is een nutriëntencombinatie die perfect kan gecombineerd worden met de klassieke chemotherapie. In vele gevallen zal IP6 en inositol de chemo versterken. En dat is toch wel heel belangrijk, omdat niet alleen de neveneffecten geweldig worden gereduceerd, maar de mensen hebben ook de kans om hun chemo regelmatig te laten toedienen. En dan gaat natuurlijk de kans op kankeroverleving geweldig toenemen. De verdere details van IP6 en inositol laat ik over aan professor Shamsuddin, die hier uitgebreid zal over spreken. So, Professor Shamsuddin, welcome here in Antwerp, and it's an honor for me and for the whole team to have you here as a speaker, and I should like to give the floor to you.
Thank you very much.
I wish you a very good lecture.
Oh, thank you very much. Thank you for coming this time of day. I know you are very busy. You have a busy schedule, and you took the time to come to listen to this. I hope I can give you some information that will be helpful to you. And what I will do is, can you hear me at the back? Okay. What I will do is go slowly and try to give you some historical perspective. The question is why they started working on IP6. What is the reason? And somebody asked me that question. I didn't answer her before because I told them that they have to wait for my lecture. So here you are. It will not be fair to give her the information. Okay. This is IP6. What IP6 is, it's myo-inositol. This is carbon sugar with 6-phosphate. So inositol with 6-phosphate is IP6, inositol hexaphosphate. Now, it used to be called phytic acid, and that's actually an unfortunate term because it is not a scientific name. The other unfortunate thing is that at one point in the history, this was discovered about 150 years ago by some German scientist, Hertig and a few others. And for a long time it was known as an antioxidant, but in the 1950s and 60s, it was named phytic acid. And it was associated with some perceived deficiency of minerals in some population in Iran and some population in Egypt who were eating unleavened bread, unpolished bread. They had deficiency of calcium and magnesium and zinc, and so without any scientific evidence, people say, oh, this is bad, phytic acid is bad. So they will stay away from the word phytic acid as much as we can. Now, it is in nature in pretty much every cereal grains. It is in rice, it's 2.2%. Corn has one of the highest amounts, up to 6.4%. Sesame also has 5.3%, it's very high. And then all the other cereal grains has it. Okay? So it is abundant in nature. How does the cereal grains get it? Well, it's in soil. IP6 is in the soil. From the soil, it goes to the seeds, and from the seeds, it goes to the plants, again back into the cereal grains. And then it cycles. And naturally, since we eat these cereal grains, one would expect that it is also in our body, correct? Now, we know that inositol is in our body. It is in our blood. It's in our serum, okay? So there is no reason why IP6 but again, there is another misconception. A lot of nutritionists felt that IP6, because it's a charged molecule, a 6-phosphate group, therefore it cannot be absorbed. So it's kind of a lot of confusion, a lot of misunderstanding about IP6, and I'm hoping to clear up some of the misunderstandings. Soy also has about up to 2% of IP6 in there. Now the question is, what made me start this work? As Mr. Verlinden had mentioned, that I had been working on colon cancer for my early research started out on colon cancer. And as I was doing the research on colon cancer, one of the things that struck me is, as you all know, the high fiber diet is protective for colon cancer. Everybody knows that, everybody thinks that. But while I was doing the research, I found out that that's not quite true. There's some large-scale epidemiological study that showed that, yes, high-fiber diet protects colon cancer. Another study said, no, it doesn't. And the third study was inconclusive. So I did some little bit more research. There was even an experiment which was done by Dr. Lucian Jacobs in the University of California in San Francisco. And he showed, his team, and he showed that by giving high-fiber diet in the mice, you can actually increase the incidence of colon cancer. So the question is, for me, although for most of the people in the news media, it's settled that high-fiber diet protects against colon cancer. But as a researcher who was more inquisitive, it didn't go well with me. I was not convinced. So there was a study that was done in Denmark and Finland in terms of the prevalence of colon cancer. Actually, the incidence or prevalence of cancer of the colon in Denmark is double than that is of Finland, both for the males and the females. But so you all know the Danes eat double the amount of fiber than the Finns do. The Finnish diet has half the amount of fiber, yet the Finnish population has half the incidence of the cancer, of the colon and of the breast. So one question is it fiber that is causing the cancer in Denmark? Or you look at the other way, what is it in the Finnish diet that is protecting the Finns from getting the cancer? Make sense? Okay. It turns out that the Finnish diet contains approximately 20 to 40% more IP6. The Finnish diet is more with cereal grains, oatmeals and some of the other cereal grains that they eat, more than the Danish population. So now is the story. Now this is in the mid-1980s, and this cartoon was taken from one of the journals showing that within the cell, and this is in the baker's yeast, in the yeast, okay? And it shows that IP3, which is inositol triphosphate, is a key molecule in signal transduction. When there's a signal comes from the outside of the cell, the signal reacts with the receptor, binds with the receptor, and it causes the cleavage of PIP2, phosphatidyl inositol biphosphate, into IP3 and a diacylglycerol. So this IP3 actually causes release of calcium from the endoplasmic reticulum, and that release of calcium causes the cell to act. Should the cell divide? Should the cell grow? Should the cell shrink? All the functions are, this is a central molecule. So back in 1980s, in the mid-80s, it was found in the yeast, but nobody had found it in the human or any of the mammalian cells. But the question I said at the beginning, that I thought of it that we get the IP6 from the soil, through the seeds, through the plants, into the grains, and we eat the grains. In our body, we have inositol. So why couldn't it be we also have IP3 within our cells? And maybe IP6 also in our cells. That was my reasoning, although it was totally against the conventional wisdom. Everybody thought that I was not only stupid, but I was also crazy. But anyway, so I tried to decide to do some experiments. But before I wanted to do the experiments, I want to share with you the fact that now we know that IP6, 20, 30 years later, the other scientists have found out, those who call me stupid and crazy, that actually IP6 and IP5 and IP4 and IP3, they're all found within the humans. Actually in every mammalian cell that has been tested, we see these inositol phosphates. And they're important in signal transduction and regulating vital functions such as signal transduction, cell proliferation, and cell differentiation. Now, we'll come to that a little bit later. So this is in the mid-80s. I had several hypotheses. My first hypothesis was that IP6 would exert its anti-cancer function through the lower inositol phosphate by entering into the inositol phosphate pool, because I just showed you that within the cells there are various inositol phosphates: inositol, IP1, IP2, IP3, IP4, IP5, and IP6. Now actually it has been found that there is an IP7 and IP8, which is a pyrophosphate. So one or two extra phosphates are added. So here is a picture back from mid-80s, when we only knew about the existence of IP3 and IP4 within the yeast. And my hypothesis was that the IP6 that we eat could be converted to IP5, and then that could go within the intercellular pool, and this IP3, which is the critical molecule, would be affected. How it is affected, I don't know. My hunch was that since the Finnish population is protected, so I would hope that by giving IP6 to the animals, they would be protected from getting the cancer. Is that clear? Okay. So to prove that, I did the studies, and first studies were to prevent the cancer, see if it can replicate the Finnish population. So at the beginning, we decided that, well, we didn't know what to expect. We didn't know whether we'll get a good result or a bad result. So we wanted to give IP6 first to the animals, and then 2 weeks later, we injected the animals with the cancer-causing agent, cancer of the colon. That was the first time, my first initial experiments were with the colon cancer, so it was a good model to study. And I want you to remember that this was done in rats. After we gave the injection, we had no idea what to expect, so we had about 100% incidence of cancer in both the groups, both the treatment group as well as the control. But the number of tumors and the tumor volume was much less in the treated group. As you can see, just about this is 3 was the tumor number of tumors as opposed to 4.6, and the size, most interestingly, the size of the tumor was 1/3. So that was a very critical clue to me, because okay, we can prevent the cancer, maybe number of tumors, but why should the tumor size be small? The tumor size should be the same. So that gave me some idea that it could not just be preventive, but perhaps it could shrink or reduce the existing tumor as well. So the next set of experiments we did, we became bolder, we became more courageous. We said, okay, now we are going to give the cancer-causing agent first. We'll wait for about 20 weeks, and by this time all the animals will get cancer, and see if we can prevent the cancer at the number of tumors. Again, you can see that the untreated animals have more tumors than the treated animals, and this data is statistically significant. We published this many times. Then we saw the dose dependence. One of the things as you very well know, has to be dose related. Do you get an increasing effect with the increasing doses? And it's exactly the same. We give the IP6 treatment, we give the control water. This time, in this set of experiments, the number of tumors where the percentage was about 58%. You give 0.1% IP6 is 46%. You give 1% IP6 is only 28%, just about half. So we do see a dose-response relationship. And this is actually the data from the actual picture of the rats that had the tumor. This is the controls in large tumors, and the treated animals had a smaller tumor. So the point is that not only you get a lower incidence of the tumors, but the tumors are smaller. That should not happen unless it is working at the therapeutic level. So that was a clue that we are into something that has a good potential. So the second hypothesis we had is that since we say that IP3 is a key molecule, the hypothesis was, again, if we add IP6 with inositol, myo-inositol, at a 1:1 molar ratio, then because there are enzymes such as phosphatases and phytases, and enzymes that can take a phosphate off or add a phosphate, phosphatases or kinases, then you should theoretically get more of the lower inositol phosphate that might give you better results. Again, it was a really, really crazy idea, because all the biochemists that, well, I didn't speak to too many, 1 or 2, and they thought that it was the dumbest thing that they ever heard. Anyway, that was not the point. But we did the experiment, and the experiment shows, the data speaks for itself. This is the cancer-causing agent, DMH, dimethylhydrazine. And you can see that if you give that, now also notice that this is in mice. So we did the experiments in rats, now we're doing the experiments in mice to show that the data is consistent with across the species, not just one species, but different species of animals. And you can see that with IP6, the incidence goes down, prevalence goes down. With inositol, also the incidence goes down, but you give the combination, you get a much better result. Some of the things, the prevalence is not quite as striking, but if you look at the number of tumors, the frequency, it is quite striking. So in a more graphical way to show is that you combine, it's a stacked bar gram, you combine the prevalence, the tumor volume, and the frequency of the tumor per mice, then you can see that IP6 compared to IP6 or inositol, the combination of IP6 and inositol gives the best result. We have done some similar experiments in the mammary cancer model. In that model, as a matter of fact, I'm not showing the data here. In that model, by giving just the IP6, you reduce the frequency, the prevalence of the tumor, but the animals that have the tumor, their tumors are larger. So there are certain companies who are trying to sell only IP6, and I think it's criminal to do that, because think of it, if you have a brain tumor and there's not much space in the brain for a tumor to get enlarged, and you give only IP6, the tumor had a chance to get enlarged. But we have the data to show that, again, when you give the combination of IP6 and inositol, you get the best result. The tumor volume goes down, the number of tumors, the frequency goes down, and the prevalence of the tumor, or the incidence of tumor, also goes down. This is a study that we did also in metastatic lung cancer. This is a fibrosarcoma model. So the previous studies were done on, so far I've shown you, in rat and mice, colon cancer. I told you about the breast cancer model in the rats. And this is a fibrosarcoma which is metastasized to the lungs. And again, the combination of IP6 and inositol gives the best results. The third hypothesis is that because IP3 or the lower inositol phosphates are common signal transduction molecule, common to every single cell, as we said, it's not just including different species, yeast, bacteria, whatever. So therefore, it should be a broad spectrum anti-cancer agent. It should be affecting, it should have data. It's not like the tamoxifen like you give, or estrogen receptor positive, or some other drug, or prostate cancer, where you have to, hormone therapy. It's very targeted. It should be broad spectrum, which sounds too good to be true, but I'll show you the data and let the data speak for itself. So how does IP6 do? It basically works by inhibiting the cell growth. And before I go, I want to show you now the human breast cancer cell line. So we have shown you the rat data, mice data, now in vitro data in the human. The MCF7 cells are human breast cancer cells that are estrogen receptor positive. And MDA-MB231 cells are estrogen receptor negative. And as you know, that the treatment of the breast cancer, depending on whether there is hormone dependent or not, the treatment is different. But look at the data here. And these are the colonies of breast cancer cells, control colonies, grown in petri dish. And you give them an increasing dose of IP6, you get an increasing inhibition of the cancer cells. So it works irrespective of the hormone. And that makes sense, because as we said, the mechanism that we think is through inositol triphosphate or lower inositol phosphate. Nothing to do with the receptor. It bypasses the whole receptor mechanism. Okay? Now, the National Cancer Institute, some of you are probably going to say, well, this is so good. Why hasn't the United States National Cancer Agency did the study or something like that? Well, lo and behold, about 12 years after we published our first paper, the National Cancer Institute decided to do, well, not 12, but 10 years after we published, they decided to do, in 1997, something called a 60-cell assay. So they have a panel of 60 different cancer cell lines, about 5 or 6 from each. This is leukemia, lung cancer, colon, ovarian cancer, melanoma, brain tumor, renal cancer, prostate cancer, breast cancer. And, and they have the 60 cells, this is called the 60-cell assay, and they give the test compound. And what they did, unfortunately, is that they were testing at 10,000 less dosage. So in our studies, we gave 1 millimolar concentration, and they started with like 1 nanomolar concentration. But as you can see, as the concentration goes up, I'm going to show you, the next slide actually is a closer picture, and you can see the data better here. So this is the concentration. This is the concentration we actually started. We used 1 millimolar concentration, and as you can see, there it's about 3 or 4 log less. And they say, well, it does not work at a micromolar level or a nanomolar level, because the conventional anti-cancer drugs are supposed to kill the cancer cells at a very low dosage. Well, notice that as they come towards the doses that we used, there is an inhibition of growth. But that's when they stop the experiment and they say, well, it doesn't work. That's another story. So, again, this is the second study they did. They repeated the study after I had contacted some of the congressmen, and they had the National Cancer Institute director have a meeting at his office, and they decided to redo the testing, and exactly the same thing. Okay, as you come towards the doses that we and other people have used, you get the same result. And every single cell line shows that it is effective. So it is a broad spectrum. The question is dosage. Okay, so to conclude this part, we and others, we started the experiment, but other people also have shown that it is effective against leukemias, lung cancer, breast cancer, prostate, colon, liver, skin, soft tissue, brain tumors, you name it. So it should be, it's a broad spectrum anti-cancer agent. How does it affect? How does it cause it? Broadly, I said that it prevents the excessive proliferation, the less number of cells, and it also causes the cells to differentiate. When the cells become, normal cell becomes cancerous, the normal cell has certain function, like the normal children in our society. You know, they do the homework at home, go to school, carry their routine work that the parents tell them to do, and you look at them, they dress more or less nicely. But then when the cells, they become bad guys, they start to look different, and they start to be rowdy, they start to go into fight. So along with this, similarly, along with the behavior, when the cancer cells become malignant, their behavior changes and their appearance changes. And with IP6, it actually causes the cancer cells to look and behave more like the normal cells. And this is the data. This is a human colon cancer cell line, a human cell line. This is a control, and you can see that with IP6 treatment, there are less number of cells. It doesn't kill the cancer cells at certain doses. At a very high dose, yes, it kills cancer cells. As Paracelsus said, the difference between poison and medicine is a dosage. You give a high enough dosage, you're going to kill everything. It does kill or apoptosis, but at a very high dose. But at the doses that we tested, we routinely tested up to 6 or 7 millimolar, it doesn't really cause the cancer cells to die. What they do is you can see the less number of cells, and the cells start to show expression of keratin. The keratin is expressed as red, and the cells have smaller nucleus, more like they behave the normal way the normal cells do. This is a mammary cancer cell, human mammary cancer cells. Again, this is the untreated control. You can see the cells, numerous cells within the same field. You can you can see that much fewer cells with IP6 treatment. And the mammary cancer, mammary cells produce milk, and the milk has lactalbumin. So when the cancer cells become cancerous, they lose their ability to produce lactalbumin, which is a marker of differentiation. And so you can see, if you stain this, both the slides were stained the same way for lactalbumin. The control cells don't produce the lactalbumin, or very little, and the treated cells actually produce a lot of lactalbumin. There are less number of cells, they're behaving more like the normal cells. And this is a dose-response relationship showing that the higher the amount of IP6, the better is the differentiation. So these are all published data. So now, having shown you the effect of differentiation, we want to take you a step further. So we have, to summarize, we have looked at colon cancer in rats and mice, breast cancer cells I told you about, the human breast cancer cells, and rat breast cancer. Now I'm going to show you the data on the hepatoma cells, liver cancer cells. The reason is that we wanted to show, as to prove the hypothesis 3, that it is against various different cancers. And we are taking a step further towards clinical trial, because just because you show some experiments where rats are treated doesn't mean that it's going to work for the human. Okay? Now, hepatomas have the ability to produce, they produce a lot of alpha-fetoprotein, and that's a tumor marker. So a practical way to monitor patients with hepatoma with effective therapy is the alpha-fetoprotein level high or alpha-fetoprotein level low? If the alpha-fetoprotein level is high, that means there is tumor is active. If you notice that if you give IP6, you can actually, with an increasing doses of IP6, you can almost totally shut down the alpha-fetoprotein production, which means that we can use that as a way not only to monitor, but it is proving that IP6 not only slows down the cell growth, not only causes the cells to differentiate, but actually shuts down the tumor marker. So it modulates, in summary, it modulates the tumor marker, and it's helpful for for patient follow-up. Now, how about we showed the data so far, it is preventive. Okay? It's critical to actually prevent, because once the patient has the cancer, it's late. Yeah. It's got a little too late. Sometimes it gets very advanced. The ideal thing would be to prevent the cancer from happening at the beginning. Okay? But we want to show that it also has some effect in treatment. So what we did is, this time we take the human rhabdomyosarcoma cells, the tumors of the skeletal muscles, and injected them into nude mice and grow them so that the tumors grow within the nude mice. So this is the closest that you can come to the clinical trial. Before the clinical trial, you have to do the xenotransplantation to show that the tumor cells, human tumors, can be reduced. And this is the result of IP6 treatment. Notice that the control, as opposed to the control group, is a huge, large tumors. There's very small tumors in here, and this is the data actually showing that it's about 49-fold less as a result of IP6 treatment. So that was also not quite a treatment, because what happened is we injected about 10 million cells per mouse, 10 million cells, and at the same time we also injected with IP6. So one could say, from a purely technical point of view, it's not quite a treatment. So this time we wanted to show that no, can we do the treatment as well. So the next experiment, we took the hepatoma cell lines. Again, we put 10 million cells, and we waited. We waited for the tumors to grow. Okay, now all the tumors, control and experimental group, they both had the tumor, and we said we're going to use a 1 centimeter size as the benchmark to start the treatment with IP6. Because now retrospectively that was a mistake. We should not have raised the level so high, because a 1 centimeter tumor in a 25-gram mouse is like a basketball for average human being, 70-kilogram human per being. But be that as it may, we waited, and then when the tumor became 1 centimeter, we started treating them. And this is the actual, the really treatment effect. And you can see that as a result of the treatment, we could shrink the tumor even after the tumor has been 1 centimeter in size. And this is the data from some of the animals. You can see that the tumor weight and the tumor size were all much less than, about 1/3 less than the control. And the data is significant. And this is, you can see that as a result of the treatment, the animals are actually healthier, even though they had the tumor, which points to our clinical trial effect, which I'll show you, that the life expectancy and the quality of life in the patients who survive, I mean, we're all going to die, but those who die with cancer at least would have a better quality of look. I mean, the animals look healthier than those. They don't have as much of cachexia, cancer cachexia as the control animals have. And this is the star of the show. And these are two siblings, two mice, who both had about 1 centimeter sized tumors. And we injected them after they become 1 centimeter. And this is the control without the IP6 treatment. And this is the animal that actually shows total regression of the tumor. Now, there have been studies that was published some in the 50s and 60s that some very famous researcher had switched the mice and said, okay, especially in melanoma in New York. But I want you to know that my postdoctoral fellow had actually accidentally hurt this mouse, and you can see the redness persisting. So it is the same animal. So there is no fudging of the data here. Okay, so now coming to the practical application of how can IP6 work with the conventional chemotherapy? And what we have shown that it enhances the anti-cancer effect of adriamycin and tamoxifen against a human breast cancer. And here's the data. We look at on this axis we have the tamoxifen, and on this axis we have the IP6 in increasing doses. And this is the reverse. We are showing the percentage of inhibition, so that higher the bars are, the better is the result. So if you give only tamoxifen, you do get some effect. You give IP6 with tamoxifen, and you can see that you have a synergistic action. And I'll come back to the tamoxifen story later on, because tamoxifen not only kills the cancer cells, but it also kills your normal cells, the healthy cells. And that's what we don't want to do. But I'll come to that when we talk about the safety. So to summarize that, the conclusion is that it acts synergistically with the chemotherapy, at least in the experimental system. Okay. So the tumor angiogenesis, formation of new blood vessel, that is a hot item, has been a hot item for some time, and we want to see whether IP6 affects the angiogenesis of the cancer cells. And where we have shown that it does affect both the endothelial cells as well as the tumor cells. And we published that in 2004. So enough of that, and what have we found in the human? And after all, we are here to treat the patients. After all those data, after I got all this, got excited, I told my mother, this is 30 years ago. I got very excited. My mother used to live in Bangladesh. She passed away 4 years ago. And I said, Mom, I'm very happy. So what happened, son? Why are you so happy? I said, Mom, I did some experiments and I showed that I can treat the cancer in rats and mice. My mom said, so what? Have you treated any human? Is this going to be good for human? So the fundamental thing is, my mother, who is not the most literate person in the world, she pointed out to me that you have to do something to show that it actually works in the human. So let's see what the clinical trial is. What is the data of that? Unfortunately, the excitement for doing clinical trial has not been much, because there is not much funding for this. As you know, to do a clinical trial, there's it's a very expensive mechanism. And the pharmaceutical industry, which has the deep pocket, they can support a clinical trial, whereas something coming out of rice and corn, who wants to do a clinical trial on that? It's not sexy, it's not fashionable. Anyway, the study showed that there is a reduced tumor growth, reduced tumor growth rate and regression of both the primary and metastatic lesions. And IP6 inositol diminished the chemotherapy-related side effects and improved the quality of life and prolonged survival. Dr. Druzianic and his colleagues presented this data in Granada in 2002. That was the earliest clinical trial. And this is the actual patient. This is the CAT scan of the patient showing that given IP6 and inositol combination. This is from September of September of 02 to January. So that's about three and a half months. And you can see the metastatic lesion has markedly got reduced just by taking IP6 and inositol. This patient refused any chemotherapy. Dr. Drugianic and his colleague also presented the very first case where they followed the patients with chemotherapy and who were taking IP6. And as a result of taking IP6 along with the chemotherapy, neither the platelet nor the white blood cell count went down. As you know, that one of the biggest complications of chemotherapy is the platelet level goes down, and that causes the patients to bleed. Sometimes they bleed to death internally. And then the white blood cell level goes down, which causes them to get infection, life-threatening infection. So if the disease doesn't kill the patient, the treatment eventually ends up in doing the job. So you don't see that effect. Now the same group actually published a clinical trial study showing the effect of IP6 and inositol in the treatment of breast cancer receiving chemotherapy in a prospective randomized clinical trial. So they looked at the quality of life index, and they show that as a result of giving IP6 gold, which is a combination of IP6 and inositol, the quality of life significantly improves. And they published that in 2010. The functional status, the ability for the people to perform normal function, also markedly increases as a result of IP6 gold treatment. Again, as a highly significant difference. The white blood cell count, again, this is before the treatment, 7.53 per 10 to the power 9 per liter. As a result of chemotherapy, as you can see, not unexpectedly, the level goes down, dramatically goes down. But whether or not you give IP6 gold before or after chemotherapy, the level does not go down, which is what what more can you do? There is no other therapy that I know of that can offer that. Same thing with the platelets. You can see that the platelet level goes down after with the chemotherapy, but if you give IP6, it doesn't affect the not as significantly. The level goes down actually right here was quite significant, and these differences are not significant. One of the things IP6 does is it repairs the DNA. There are multiple different mechanisms how it works. One of the mechanisms is that causes DNA repair. As you know that in radiation damage, it does cause the damage. Radiation causes damage in the DNA, whether it's ultraviolet light or it is gamma radiation. It does cause the different kinds of injury, called acute injury and chronic radiation injury. And what happens in IPS, there are acute injuries or acute radiation syndrome, which we talked about, pancytopenia. There are gastrointestinal disorders, diarrhea, mucositis, cutaneous and neurovascular complications. And IP6 as an antioxidant can help. I mentioned about the DNA repair. IP6 by repairing the double-stranded DNA breaks, and these are all published. These are not my data from other people that show that it can actually indeed inhibit the signal, ultraviolet B-induced signal transduction. So it can do both the acute, it can protect against the acute radiation damage. It can also protect against the chronic radiation effect. And the results, the effect of chronic radiation effects are increased fibrosis, increased cell division, and eventually cancer. And as you have seen that, I've not shown you the data on IP6 as anti-inflammatory, but I will show you some paper. It is an anti-inflammatory agent, and of course it normalizes the abnormal rate of mitosis. So therefore, and it has a broad spectrum anti-cancer effect. So that's why I think that radiation, IP6 can prevent radiation-induced damage. The studies by my colleagues at the University of Maryland, actually on a rat, on ultraviolet UVB-induced radiation skin cancer, which is a common cancer as a result of sunbathing. You spend your summer in the beach and you're always worried about whether you're going to get skin cancer or not. So this is to show you that by giving 2% IP6 in drinking water, you can actually dramatically reduce the tumor incidence and the number of tumors per animal by giving IP6. And this is in the drinking water. They have also studied by giving IP6 as a skin cream, and they have shown this pretty much the similar data. So it is something to consider in terms of the skin cancer that happens as a result of our daily normal activities, especially in summertime. And this is a study that was published in Spain showing that IP6 actually has the ability to chelate uranium. And I will just read the concluding sentence. The results showed a strong affinity of inositol hexaphosphate for uranium, suggesting that it could be an effective chelating agent for uranium in vivo. Okay. Now, there's a case I want to point out to you, and that is going to be a transition of going to another chapter. Jenny R. is a 40-year-old Caucasian female. She's actually Canadian, and she had the diagnosis of a precancerous lesion of the uterine cervix. Her brother happened to be a physician, a naturopathic physician who actually who written a book on IP6 also. If they found that Jenny at the same time had osteopenia. Now, osteopenia, as you know, is not osteoporosis, but the earlier stage of osteoporosis. And Jenny was 40, so brother gave her IP6 inositol, it's IP6 gold, 8 capsules a day, and 6 months later, her pap smear was totally normal. So here's a situation that the precancerous lesion has been totally reversed. The beauty is that, as a bonus, 2 years later, her DEXA scan showed that Jenny did not have any more osteopenia. As a matter of fact, her bones were as healthy as a 20-year-old woman. And by that time, Jenny was about 42, 43 years of age. So that brings us to the issue of osteoporosis. As you know, that osteoporosis is a very common disease, especially in the elderly, particularly in the females. And this is a slice of the vertebral bone showing the normal, healthy bone and an osteoporotic bone where there are a lot of empty holes and spaces, which makes the bone very fragile. So if you hurt yourself, if you lift, you have the risk of collapsing the vertebra, and that can be very, very, not just painful, but also very debilitating. In terms of osteoporosis, the fundamental thing is there are 2 different cells in the bone. One is called osteoblast, that produces the new bone, and the second one is the osteoclast that resorbs, that eats up the bone. So this is a continuous process that goes on. Obviously, if you lose the balance between the bone formation and bone destruction, then you are having a disease problem. And this is the histological slide showing the osteoporotic area. This is the bone, and these are the small cells that you see. They're the ones that lay down the bone, a single cell. And then there are the giant cells, multinucleated, large cells with many nuclei, that eat up the bone. As you can see, they're eating up the bone. So this is what goes on. The osteoblast lay down the bone, and osteoclast eat the bone, as the name indicates. Now, you all know that those patients who take hydrocortisone, they are osteoporotic. And what hydrocortisone does is it actually, we look at the osteoblast cells. These are the cells that lay down the bone. And you look at the number of cells by doing a spectrophotometry, and you give 10 microgram of a micromolar of hydrocortisone, the level of the number of osteoblasts goes down dramatically. Whereas if you give IP6 along with that, the level actually stays the same, if not better. So the message is that IP6 causes the osteoblast cells to be resistant to hydrocortisone treatment, and it causes the cells, makes the cells better. Okay? The osteoclast cells, which are the ones that eat up the bone, you want them not to be active. You want them to be less active. And that's exactly what hydrocortisone does. Hydrocortisone actually causes the osteoclast cells to be more active, but with IP6, you actually get a suppression of the osteoclastic cells. So there are, on one hand, and actually I have a summary slide, the steroids cause the bone-forming cells to go down. It causes the bone-removing cells to go up. And IP6 just does the opposite. And I think I've showed you that the study of Janie's case. Now, in Spain, in Mallorca, they have done, Professor Felix Grases and his colleagues in the island of Mallorca in outside Spain, have done a study on about 1,500 patients looking at their dietary habit and checking their diet and what they eat and their correlation with osteoporosis. And they conclude, they conclude that the IP6, so they call it phytate, may reduce the bone mineral density loss. And this compound may be used in the primary prevention of osteoporosis. And they published that in the year 2008. Now, I'm coming towards the end of my talk. Almost done here. This is another way to look at IP6, again, a myoinositol ring and the 6 phosphates. And these are the abilities, the negative charges on the phosphate allows for the mixture of, for binding with the divalent cations, the positively charged calcium, magnesium, iron, and so on and so forth. So by its ability to take the iron, it causes, so the iron causes in the cells, it causes the production of hydroxyl radicals. So by removing the iron, which IP6 does, it causes the reduction of formation of hydroxyl radicals. So it's an antioxidant. And I'm not going to, I don't have much data on the antioxidant, but I'll show you other people's data. This is a paper that was published in 1995 by Northwestern University in Chicago, and they've shown that IP6 can actually attenuate the inflammation and fibrosis. I did mention to you that IP6 reduces the inflammation when I talked about radiation damage. And here is the actual paper that as a result of asbestosis in rat experimental model, they have shown that IP6 reduces or even prevents the formation of fibrosis. And here's an interesting thing. If a patient has a heart attack, a myocardial infarct, as a result of myocardial infarct, you have a damage in the heart. But when the collateral circulation starts to bring in the blood from other sources, then actually what happens is the size of the infarct goes up because the fresh blood brings oxygen, and that oxygen actually causes more damage. And Dr. Rao and his colleagues have shown in Connecticut and Albert Einstein College in New York have shown that if you put IP6 injected intravenously, you can reduce the ischemic damage. In other words, the so-called reperfusion injury does not happen. That's fascinating. What more can you ask for? I mean, it just gets better and better. So it protects the heart during myocardial infarction. We have done some studies to show that the aggregation of platelets, which is very critical for atherosclerosis and coronary artery diseases, IP6 can, if the increasing doses, it can prevent the aggregation of platelet. So in summary, it has the IP6 prevents the platelet aggregation. There are studies that have been shown that it lowers serum cholesterol, and Professor Grasses have shown that it can prevent atherosclerosis as well. I'm coming towards the end. This is John. Mr. John is a 65-year-old Caucasian male. This is about 20 years ago, 20 years ago, that he had a stroke with 94% occlusion and 90% occlusion of his carotid arteries. So the surgeons did endarterectomy on the worst, in the 94% cases. And that was the only one that did it. So his son, again, is Dr. Van der Linden. He started treating his father with IP6 Gold for 4 capsules twice a day, 8 capsules a day. And guess what? 3.5 years later, nothing has changed. The one that the physician cleaned up, 94% occlusion cleaned up. Normally, as you know, that once you do the endarterectomy, the atherosclerosis gets back again. You have to do a second surgery. He didn't need a second surgery. And the artery that was less occluded stayed the same. So there was no progression of the disease, whether the diseased artery or the cleaned up artery. The bonus in his case was that he had a bladder cancer and he doesn't have it anymore. Okay? Now, with that, I'm going to transition from bladder to kidney. Again, coming towards the end. This is Professor Felix Gras's study from Spain, showing that this is a slice of the kidney in rat, controlled rat with a kidney stone, IP6 treated rat with no stone. So it does prevent kidney stone formation. It also has effects on diabetes. IP6 is important in glucose-stimulated exocytosis of the pancreas, and it regulates the insulin secretion by the pancreatic beta cells, and that was shown by the study group from Karolinska Institute, and it also prevents the complications of diabetes mellitus. And there's a study that was shown that inositol itself prevents and reverses the endothelial dysfunction in diabetic rat and rabbit vasculature, blood vessels, by scavenging. So inositol is also an antioxidant. Both IP6 and inositol are both antioxidants. The question is how safe it is. You're going to say, well, it has done all that, but is it safe? And the fundamental question that people always had is that it chelates the calcium and magnesium and divalent cations. And this is a lifetime study of the animals and showing that it does nothing. This is IP6, inositol, and the combination. There's virtually no difference in terms of calcium and magnesium or any of the minerals. And this is a serum level. Some critics said that, well, could it be the bone? Have you checked the bone? The bone level is more reflective of a long-range problem. So we tested that also. Again, calcium, magnesium, and zinc. There is virtually no difference in the level. So it doesn't do anything. There's no harm. We talked about the tamoxifen killing the white normal cells. This is normal human peripheral blood mononuclear cells. And IP6, increasing doses of IP6 does nothing to the normal cells. Same level of Taxol actually causes the normal cells to die. So bottom line is it doesn't affect the normal cells. As I mentioned to you, IP6 is in the normal concentration in the human plasma is about 400 nanomolar in range. A level depends on its intake. So if you eat a healthy Mediterranean diet, nuts and legumes and cereals, or the Finnish, the oatmeal and porridge, they have a good amount, healthy amount. The human become deficient as little as in 2 weeks' time. If you stop eating the healthy diet in 2 weeks' time, your level goes down. And that study was done by Professor Grasses in Mallorca. And to obtain an adequate IP6 level, more than 10 days are needed if you want to eat only the healthy food. So if you're made deficient, as a matter of fact, he had several volunteers. One of the volunteers was a colleague of mine, Dr. Vucenic. So she went to Mallorca, and they were all doing these experiments where they all were deficient in IP6 diet, and then they tried which one works, how it works. And that was published in Life Sciences in 2002. So it takes about 10 days for them to be back to normal if you take only the diet. But it takes only 4 hours if you take the supplement, and that's where Mr. Verlinden comes in. In terms of the doses and pharmacokinetics, if you take it within 4 hours, if you reach the peak plasma value at 4 hours, it goes up to 8 hours and then falls down. So therefore, a typical regime would be 2 or 3 doses per day. Summary of, again, I think it's a overkill. It prevents and treats cancers, inhibits kidney stone, lowers serum lipids. There are studies that have shown that it prevents the fatty liver formation. Also studies shown that it increases the oxygen carrying capacity. I've written a couple of books on this. As a matter of fact, we're going to put the books on the webinar, and you'll have the reference to that. And also it's on the website, so you can get a link to the websites, to the book. IP6 actually enhances the host defense against cancer and microorganisms by increasing the natural killer cell activity. And we showed the paper on the ischemic myocardium, protects the heart against myocardial damage, and it prevents atherosclerosis. Inositol by itself also prevents cancer. It prevents the complications of diabetes. It actually had been used in the treatment of depression and panic disorder. And it prevents the birth defects in children of a diabetic mother as a result of diabetic embryopathy. It also prevents fatty liver. So it affects the signal. The combination of IP6 inositol prevents the cell proliferation, induces differentiation, affects the signal transduction pathways. In high doses, it does cause the cancer cell to die, as I mentioned to you, in apoptosis. And is cancer preventive and therapeutic either alone or as an adjuvant therapy. So some patients would refuse standard therapy, chemotherapy, and this would be a choice for them. So the combination of IP6 as inositol is basically what is packaged as IP6 Gold. And finally, the dose recommendation, how much should be given. You take, for prevention, take 2 capsules twice a day. That's what I have been taking for the last 18 years, 18 years, 17 and a half years. And I'm not dead yet, so it's safe. I'm a living proof of that. For therapy, it's recommended that you take the capsules 2 to 3 times a day because of the pharmacokinetic study that I have shown you, that the peak plasma value goes up at about 8 hours and then starts to fall down after 8 hours. So 2 or 3 doses per day within 24 hours would be the optimal. Okay? The information is ip6gold.com, and ip-6.net is the websites that you can get the information from.
Also give the link of your book.
Huh?
The book
Yeah.
for the professionals.
Okay, yes, I will give the link. Actually, this website, ip-6.net, if you go there, there are links to the books for the professional as well as for the public. And then Dr. Van der Linden has a book that is also there. You can read it online from there. Okay, I think I'm almost done.
Yes.
Right.
I would like to thank you for the interesting presentation. Voor de aanwezigheid.
Sorry that I was
Yes, sir.
too late to show here at the beginning, but in my practice I use it a lot for antiviral treatments. I didn't hear something about the antiviral. Was it at the beginning or?
No, I didn't talk about it, but I'm glad you asked that. I've already shown so many things that people are going to say that, oh, it's too good to be true. It does cure everything, it does everything. No, there are studies that have been shown that actually in AIDS, it does inhibit the AIDS virus, HIV replication. That study was done in Japan back in 1980, towards when HIV was just started to come out. I can tell you from my personal experience that I haven't had a flu in the last 18 years, no flu. Common cold, once in a while I started to have a scratchy throat. As soon as that happens, I take 4 capsules 3 times a day, kiss goodbye to common cold. I haven't had a full-blown common cold, probably twice within the last 18 years, because either I was negligent, I ignored the symptoms, and I said, it's nothing. But thank you for actually pointing that out. It is. Well, it does, because it's not only it affects the viral replication, but it also boosts the natural killer cell activity. The data I haven't shown. I already have shown too many slides. I didn't want you to fall asleep. But it does boost the natural killer cell activity, and as you know that the natural killer cell activity is important for viral, fungal, and bacterial disease, as well as cancer, in defense of the cancer. There are a study was done by Dr. Paul Eagleton over in, he was in University of Exeter in England, and he has shown that the actual killing it is well known that when you have a bacterial infection, the polymorphonuclear cells engulf the bacteria. The actual killing of the bacteria is done by hydrogen peroxide and free radicals. Now here is the interesting thing. On one hand, IP6 is an antioxidant, okay? But in cases of in case of bacterial phagocytosis and bacterial killing, it increases the amount of oxidative free radicals and ability of the bacteria of our body cells to kill the bacteria. So it has a dual function. I mentioned to you that it does do nothing in terms of the normal level of the calcium, magnesium, iron, and zinc, but patients with hemochromatosis with a very high amount of iron, or patients with Wilson's disease with a high amount of copper, they have taken IP6, their iron level and copper level has dramatically gone down. I have reports from them, basically self-reporting, telling them how dramatically they have improved. So, there you go. Yes, sir.
A question about hemochromatosis.
Yes.
What dose would you recommend then?
Basically, the therapeutic dose, 8 capsules 2 to 3 times a day. Yeah.
Yeah. And biochemically, how would you explain most of the effects in the human body, so the positive effects in terms of cancer, osteoporosis, all these things? There must be some common mechanism that is enhanced by IP6.
You're absolutely right. I think fundamentally it's like a vitamin, as Mr. Berliner has initially said. I think every single cell has it, we all have it, and we get it from our diet. A study was done in South Africa. If you look at the South African Bantu, they eat about about half a kilo of corn, maize diet every day. And they don't get cancer, no kidney disease, no diabetes, no atherosclerosis and heart attack. When the Bantus moved to Johannesburg, the first generation still maintains their corn diet and they're still fine. The second generation starts eating McDonald's and Burger King and not eat the corn, and they're getting their incidence of cancer, diabetes, heart disease, all of that is the same as the white Afrikaner. So it is something that is in every single cell, and we're deficient in it, and we just have to do it. If you can take a healthy diet, but you have to eat half a kilo of corn every day to be sufficient, or you can take the supplement. That's, I think, is the point. Yes, sir.
To have a good absorption of your product, you need a good digestive system. And to have a good digestion of your product, you need a good digestion system. But in the case of a digestive system, you need quite a lot of zinc.
Yes.
Otherwise, you have a leaky gut syndrome. My question is, all those patients, I think the preventive, we should have look first at the state of the zinc, because it's a common element. Has it no interaction with IP6? Zinc okay, IP6 good absorption, zinc low, bad absorption.
I think that has been shown. That's a very good question. Yes, if the level of zinc actually of any of the nutrients is low, then it affects it adversely. Yes, you're right. But with the normal status, if somebody has a normal diet, normal mineral status, it does nothing. You're absolutely right. Yeah. Yeah. Did I answer your question?
Yeah, yes.
Okay.
Thank you. I'm wondering how it works at the molecular level. You didn't show any data about
Right.
this. Then probably you have, I presume you have these data, and I would be highly interested to see.
Yeah, I saw you falling asleep, so I didn't want to show the data. No, I already showed too many slides, and it's already over an hour. I think it'll be... No, there's numerous molecular functions, numerous pathways by which it does. Well, first of all, there is a cellular mechanism. I said cell differentiation and cell proliferation. There are natural killer cell activity. Briefly mention about the DNA repair. It does damage, enhances the ability of the cells to repair the DNA. That has been done. It boosts the p53 level. It affects the WAF1, P21, WAF1 level. It does work in terms of the some of the RAS oncogenes as well. So it does work in multiple different ways. I didn't show those slides. Yeah.
Do you know?
It's all in that book, and you can read it. Yeah.
Do you know anything about how it works at the mitochondrial level?
That's a fantastic question. That's one of my. The question is, do I know anything about does it work at the mitochondrial level? And I think Professor Otto Warburg would be very happy to hear that. I'm sure he's very happy, smiling. I had been a mitochondriac. I always believed that there is something mitochondria has the ability to play a key role in terms of cancer formation. But I haven't really pursued as in my early days when I did a lot of electron microscopy of the cancer cell. I clearly saw distinct changes in mitochondrial morphology in the cancer cells that you never see in the normal cells. Yeah. But I haven't pursued it. One thing I can tell you that mitochondria is the powerhouse of the cell. It produces the ATP. It's responsible for the generation of ATP. The question is, what is ATP? Adenosine triphosphate, right? Well, where does the phosphate come from in the body?
From bones.
From bones? But where does the bone get it from?
All the food I go.
There you go. And what food? The cereals, IP6. So that has something to do with the energy, with the phosphate. But I think that's a fascinating area to study. I don't have any data, but I would love somebody to do that. I would like with Dr. Warburg, I'd be very happy if somebody did that. Yeah. That's a fascinating area to study.
Okay, I have another question. Are there proven positive results on the use of IP6 in patients with colon cancer?
Oh, absolutely, yes. That has been published. There was an international conference of anti-cancer research in Corfu, and that was several years ago, and several doctors presented the data, and yes, it has been proven to be effective. Well, one of the problems is that when you offer a conventional therapy, then if the patient has a right to choose not to take the conventional therapy, then they can take only IP6 gold and then say, okay, this has happened. But in patients who refuse the conventional therapy and decided to take only IP6 gold, they have seen positive results, as a matter of fact. Cure is it, but remission. There are a lot of people who have reported remissions, yes.
Another question, could IP6 help for patients with lung sarcoidosis?
It certainly is possible because, as I mentioned, that it does prevent the inflammation. So in sarcoidosis is a disease where you do get the granulomas within the lungs and you get fibrosis, and it could certainly help, but I have no data on that. I had that question from another physician some time ago, but I don't have the data. I didn't have any feedback from them either, so I don't have an answer. Yes, sir?
Is there any influence of the pH of the blood on the AP6? Because normally the patients are acid or alkalic.
Right. Okay. The question is there any effect on the pH of the blood by IP6? The answer is I don't know, sir. I don't have the data. Yeah. That's a very good question, but I don't have the data. Yeah.
It will increase the
I don't know. I don't know what to do. It could probably, yeah. Yeah. It could probably, yeah. It is somewhat alkaline, actually. Calcium, magnesium, IP6 is somewhat alkaline when you, yeah.
Is it to do with a second messaging?
Yeah.
So second messaging is an important function of IP3 in
Yes,
the cell.
correct.
Is this has this mechanism a major influence on how a cell behaves?
Yes. Yes.
Either like a cancer cell, either like osteoblast, osteoclast, and so on and so on.
Absolutely, yeah.
So, but this is a biochemical question, of course.
Right,
This is,
right,
yeah.
right. The central mechanism, I think, is that one of the central mechanisms is that it works through IP3 and the other signal transduction molecules. There is a constant shift between IP6 and inositol. It's like chicken and egg. IP6 can become inositol, inositol 5-phosphate, 4-phosphate, or the reverse. Yeah. And I think that is the critical central mechanism. You're right.
Which enzyme is involved in it?
Which enzyme?
Enzyme, I mean going from IP6, IP5, and so on.
Right, phosphatases,
from
yeah.
top to bottom or bottom up.
Yeah, there are quite a few different enzymes, and the biochemists are actually very hard working at figuring out what enzymes they're doing, and they're the ones who actually don't think that it happens in the human, but that's another issue. Yeah. Yes, sir.
Normally in the cell you have two kinds of DNA.
Mm-hmm.
You have the DNA normally in one cell you have two kinds of DNA. You have the DNA in the genes,
Yeah.
the chromosomes. You have also the female DNA in the mitochondria.
Yeah, yeah.
Is the IP6 working on both of them?
The question is, normally the cells have two kinds of DNA. There are DNA within the nuclei and DNA in mitochondrial DNA. And does IP6 work on both of them? The answer is I don't know. It's quite possible why it shouldn't be, because it does go in the cells. It goes within the nucleus. We have done the when we did the testing of absorption of IP6 with the radioactive IP6, it does go into the nucleus. It actually goes into the mitochondria as well, coming back to the mitochondrial question. But does it affect? We don't have the data. Yeah, that's a great question. Yeah. Dr. Warburg is very happy.
Oké, wat ik nog zou willen toevoegen is dat de IP6 en inositol verkrijgbaar is in capsules, maar ook in poeder. Dus tijdens de presentatie is een paar keer gesproken om een hoge dosis capsules te nemen. Dat kan eigenlijk gemakkelijker via poeder genomen worden, wat ook aangenaam is van smaak. Het lost heel goed op in water, dus ik denk dat dat een goede oplossing kan zijn bij kankerpatiënten of bij andere toepassingen.
Wat is de vergelijking met de capsules van de poeder?
1 maatbeker van het poeder komt overeen met 8 capsules. Dus als je 2 maatbekers per dag neemt bij bepaalde vormen van kanker, komen 2 maatbekers overeen met 16 capsules. Preventief 2 maal 2 capsules per dag. Anders een half maatje. Dat is ook perfect mogelijk.
May I add something? Yeah. May I add something?
Yes.
Okay. One of the questions that I get from the patients all the time is that how long should we take a patient who has cancer? Pardon? Every day for how long? Whole life. That's exactly the answer. And I've been taking it for 17 and a half years now, and I can plan to take it for the rest of my life. The patient who has cancer, and a lot of times the patient become very, they say, well, they get a result, they get a dramatic result, and they say, well, I don't want to take it anymore. That's a big mistake, because cancer is a very, as you all know, is a very, very dangerous enemy, and you can't be complacent about it. My standard rule is one has to be absolutely, totally disease-free for at least a year before they can go into an intermediate maintenance dose. So we talked about the prevention for healthy people, which I take 4 capsules a day. I took it this morning. And for treatment, I said 8 capsules 2 to 3 times a day. It can go higher. Some people can, if they want to take higher dose, that's fine. There's no toxicity. For somebody who had been in remission, they should be taking an intermediate dose. I said 4 capsules 3 times a day, or 6 capsules twice a day, something like that. Something intermediate that they're comfortable with, because and then the other thing is some patient they decide to stop taking it for a while, and they say, okay, I want to take a drug holiday and then come back again. That's a big mistake. When they do that, the cancer comes back, and it is almost like with a vengeance. They become it's totally uncontrollable. Yeah. But you have the experience, yes.
Ja, dus ik denk dat het een heel interessant product is, IP6 Gold, om in te zetten in tal van aandoeningen. Ik wil professor Shamsuddin nog eens bedanken voor zijn interessante voordracht. Ik wil alle mensen bedanken die hier vandaag aanwezig waren. En ik wil ook nog eens alle mensen bedanken die het webinar gevolgd hebben. En ik zou zeggen tot een volgende maand. Dank u wel.
Thank you. Thank you. Well, thank you for staying awake, not falling asleep.